All right, another example on Lenz's law. Let's say we have two rails here, and you have a rod, and there is a magnetic field, for instance, that is directed into the page. There is a magnetic field directed into the page. This is B. And I am moving this rod, all of them are conductors, moving it to the right. Okay, with a, let's say, velocity V. With a velocity V. And let's say the length here is L. So first of all, I want to know what will be the direction of the induced current in the loop or in this rod. So here, pay attention, we have to follow Lenz's law. So according to Lenz's law, if I am moving this rod to the right side, so you can notice that the area, this area here, is becoming bigger. So if the area becomes bigger, then the flux will increase, because remember the flux, it is B multiplied by A multiplied by cosine the angle. So if the area increases because you are moving the rod to the right, so imagine if you move this one to the right, now the area becomes bigger, the area of the coil here becomes bigger. So area becomes bigger, then the flux is going to increase. Now according to Lenz's law, if the flux increases, those are the steps of Lenz's law, then the B induced should be opposite to the B original, to the blue B, which is the original magnetic field. All right. Now, if this B original is into the page, if this B original, okay, is into the page, then B induced should be opposite to it. What's the opposite of into the page? Opposite of into the page should be what? Out of the page. So this means B induced is out of the page. So this is B induced. It is out of the page. Okay. Now we do the right hand rule. Remember, this is the right hand rule. If B induced is out, so look at the current. It's going to be counterclockwise. So simply the current is going to be counterclockwise. So this is I induced. So the current in the coil is going to be counterclockwise. So what will be the direction of the current in the rod? In the rod, it's going to be upwards. If you have a resistance here, so the current is going to be downwards, and so on. This is regarding the direction of the induced current or induced EMF if you want. What is the induced EMF here? The induced EMF, okay, we simply apply the motional EMF law directly. So the induced EMF, it's equal to the magnetic field multiplied by the length multiplied by the velocity. So any rod moving in a magnetic field, that will be the induced EMF in the coil. It's equal to B times the length of the rod, this length, multiplied by the speed. And if we need to find I is simply the EMF divided by the resistance. So if you have a resistance in the wires, then the I will be the EMF over R. Okay, we can take some values. Let's say B is given to 0.2 Tesla. Let's say the velocity is 5 meters per second. Let's say the length is, for instance, 10 centimeters. So you just substitute here. And let's say the resistance of the wires R equals to 10 ohms. Then what will we get for the EMF? So the EMF will be, in this case, 0.2 multiplied by 10 times 10 negative 2, because we changed from centimeters to meters, multiplied by the velocity, which is 5. All right, so you have here 2 multiplied 5, 10, 10 times 10 negative 2, 10 negative 1. Okay. Yeah, 10 power minus 1. Okay, so it's 0.1 volts. That's the EMF. And I will be E over R, the induced voltage. E will be the 0.1, and the resistance is 10 ohms. Okay, so it's simply gonna be 0.01 amperes.